Okay, so we evaluated the critical points and the endpoints, and we get, these are our values. So next we're just going to name the absolute min and the absolute max. So in this particular case, we would say the absolute min is -1 at x equals 1. What about the absolute max? Is 16 at the value x equals what? 2. So basically that's what you'll identify there. So we, as the guideline suggests, we evaluate f at all the critical points, which we take the first derivative, set it equal to 0 to find our critical points. We make sure those critical points are in our given interval, and then we proceed. We test the critical points, and we test the endpoints to determine what's going to be the absolute max and absolute mins. Okay, let's just try another one. Let me go to, I need a new page. Yeah. Back up to here. Got it. All right. Let me go out to a blank page then. Alright, so your next one, I want you to, I'm going to give you this function to be f of x is equal to 3x squared minus 7x plus 5. That's your function. Your interval is from -1, excuse me, -1 to 2. Okay, so I want you to find your absolute min and absolute max. Okay, so the first thing you want to do is set your first derivative equal to 0 to find your critical point. In this case, we have one critical point, 7, 6. So the next step is to evaluate your function at the critical point. Make sure this is in the interval, which 7, 6 is in the interval because it's a little more than 1. And the next thing you're going to do is evaluate your critical point and your endpoints. So go ahead and work on that. Okay, so here's where we evaluated our f at the critical point. We get 11/12. At endpoint, we got 15, and at the other endpoint, we got to be 3. So which one is our absolute minimum value? The absolute min is going to be here. Let's label that. So this is your absolute min. And it occurs at the x value what? 7/6. Which one's the max? 15. The absolute max is 15. And it occurs at the x value -1. Alright, we have a new function, f of x equals x cubed minus 3x, a new interval, so between -2 and 0. Go ahead and determine your critical points, and then test the critical points that are in your interval and the endpoints to determine the absolute min and max. So I'm going to pause it so you can work on that. Okay, the first thing we're going to check before we move forward is that when we evaluate for our critical points right here, we have that one which goes away. We have -1 and +1. What about, is -1 in our interval? Yes, but what about +1? It is not. So basically, we're not going to use this one. because it's not in our interval. So when we're evaluating over here to the right, we're going to evaluate the critical point, so f at -1. Then we're also going to evaluate the endpoints, which are going to be -2 and 0. So this was our only critical point in our interval, our endpoint, and an endpoint. So go ahead and test those to let's determine mins and max. Okay, so we test our values. Critical point, we get a value of 2, endpoint -2, and endpoint 0. So the absolute min of what occurs at x equals what do we put here? Absolute min is -2. Good. So let me plug that in. And it occurs at x equals -2. Good. What about the absolute max? 2 occurs at x equals -1. Good. Okay, we're going to work with the trig function here. So we have sine of theta. The interval is -pi/2 to 5pi/6. Let's take our first derivative and do our critical point. So what's the first derivative of this function? Cosine theta. Good. Okay, so the next thing we need to do is set cosine of theta, our first derivative, equal to 0. So what values are the cosine of theta equal to 0 on our interval? So -pi/2, cosine of theta is equal to 0 at -pi/2 and also at pi/2. And these are your critical points. Remember on your unit circle that the cosine of theta is which value? Your x value or your y value? X. Good. So it's where is your x value 0 on your unit circle in our given interval? So at -pi/2 and at pi/2. So we've established that. Then we want to evaluate at our critical points. So we evaluate f at -pi/2. This is a critical point. Then we want to evaluate f at +pi/2. That's the other critical point. And what about our endpoint? Our endpoints are -pi/2, but we don't have to do it again because we'll already know the value for that. But we do need to account for this one since we haven't done it yet. So let's do 5pi/6. Up here, this is just going to be the sine of -pi/2. So if you have your unit circle out, you can look at that. What's the sine value at -pi/2? -1. Good. What about sine of pi/2? +1. Look at your unit circle if you just need a refresher on this. Sine of 5pi/6. 1/2. Okay. So what's going to be our min? Our absolute min is here, and it occurs at -pi/2. So this is our absolute min. And which one's our absolute max? Absolute max is 1, and it occurs at the x value or theta value pi/2. Okay, last one on this, and we'll move to something a little bit different. Our interval, let me make sure you have that, is between -2 and +3. So first thing I want you to do is work on your critical point. So take the first derivative, set it equal to 0. Okay, so when we're doing the derivative of this, let's talk about this particular case. So we just get this as our derivative, we set it equal to 0. Just to make the algebra a little more simple here, we rewrite it in terms of square root of x, and we put 0/1 so we can just cross multiply here. In this case, you get 2 is equal to 0, which is a false statement. So basically, we conclude that there's no critical points when the first derivative is equal to 0. But if you recall the handout when it said there's an interior point of the domain of the function when we either have the numerator, the first derivative is equal to 0, or if it's undefined. So the first derivative in this case is undefined in what particular case? If we're looking at this, it's undefined when x equals 0. So this is going to be the case where the critical point's determined by where the first derivative is undefined. So now from this point we'll proceed on and we evaluate f at 0 since that was a critical point. And then our endpoint, so our other endpoint is going to be f at -2, and then you're going to evaluate f at 3. Okay, so we evaluate f of 0, that's our critical point here, and we get 0, which ends up being our absolute min of 0 at x equals 0. And then we come down here, and this is our max, 2.08 is our absolute max, and it occurs at x equals 3. So what we learn in this one is that sometimes we don't get a critical point when the first derivative is equal to 0, but then we need to check to see if the first derivative may be undefined at a value of x. If that's the case, then that will be a critical point.